Right, year 11, it's the next lesson. You'll be working through exercise 6F on page 183. It's a section just called miscellaneous exercises, and as you know, I'm on camp this week, so I just there will be a maths teacher hopefully in the class to give you a hand. I'd just like you to work through the work requirements on 6F, but what I thought I'd do in this YouTube is just do one or two of the questions just to give you an idea of the type of what sort of response they're after, perhaps just help out as you work through. But I'm not going to do the questions that are on your work requirements, which are 2, 4, 8, etc. I'll do questions 1 and 3, as I said, just to give you an idea of the flavour of the questioning. So in question 1, so what it basically is doing is it's taking function notation and asking not unfamiliar questions, but in perhaps unfamiliar formats because of the function notation. So if f of x equals ax plus a plus bx, sorry, this is question 1, a plus bx, and f of 4 is equal to minus 1, f of 8 is equal to 1, and in part A we're asked to find a and b. Okay, what can we do with this? This is our function definition here, a plus bx. F of 4 equals minus 1. If f of x is a plus bx, f of 4 will be a plus 4b, and that's equal to minus 1. So there's equation 1, and f of 8 will equal a plus 8b, which is equal to 1, so that's equation 2. Now what I'm going to do is I'm going to subtract up the page, so I'm going to take equation 2 and subtract equation 1 to get a minus a 0, 8b minus 4b, 4b, 1 minus minus 1, 2, b is going to equal to a half, and therefore in equation 1 a plus 4b, which is now 2, equals minus 1, so a will equal minus 3. So there's my two solutions for A and B in question 1a. In question 1b, we are asked to solve f of x equal to 0. Solve f of x equal to 0. F of x is a plus bx, but we found out what a and b are. So f of x is now minus 3 plus 1 half x. I'm going to solve that equal to 0. So a half x equals 3, and x is equal to 6. So that solves that function equal to 0. So that's the style of question 1. Perhaps question 2 is similar. 3 is quite similar to that also. You're going to do question 4. Just looking down, you're then going to do question 8. Perhaps if I do question 5, I said I was going to do 3. I've changed my mind. I'm going to do question 5. Having done question 1, I think question 2 is 3. Sorry, is very similar to question 1. So if we have a look at question 5, and we're told here, a function is defined as 3 minus 2x, and we want to find f of p plus 1 minus f of p. So if we put p plus 1 into this function, then that'll be 3 minus twice p plus 1. Remember, we just feed in this value to x here. Simplifying, 3 minus 2p minus 2, so it's 1 minus 2p. But also want to know what f of p is, which is just 3 minus 2p. So I've got my f of p there, I've got my f of p minus 1, so therefore f of p plus 1 minus f of p is equal to 1 minus 2p minus, let's be careful here, we subtract all of fp, so we need a bracket 3 minus 2p. So now in removing that bracket, it's minus 3 plus 2p, which is equal to minus 2. The minus 2p plus 2p goes, and that's our result for question 5. So this is the style of question in exercise 6F. It obviously goes on, gets right through. You'll be looking at questions 10 and 12 as well. In 12, you've got A, C, and E to do. Perhaps I'll just do B, so 12B. So in fact I'm doing 12B as well. Come down the page, 12B. If you have a look at page 183, then you'll see the question that I'm doing. It's asking state the implied domain and range of each of the following relations. You're going to do A, C, and E. I'm going to just have a look at B. So domain and range of this function here. Okay, it's an x squared and y squared. It's a circle. So you can very quickly sketch this by recognizing my center as 2, 0, just here, with a radius of 1. Remember the equation, the general equation of a circle is x plus h squared plus y minus k squared equals r squared. R is the radius, hk is the center. So in this case, the center is 2, 0, and the radius is equal to square root of 1, which is 1. So 2, 0 is my center, radius is 1, so it's a tiny little circle. If I've gone to scale here, then this thing is just going around like this. And we draw that circle. State the implied domain and range. So the domain, so implied just means natural, without placing any restrictions. The domain is, okay, how high are we going here? So sorry, that's what? That's 2, 0 there. So this is the point 3, 0. This is the point 1, 0. So we're going from 1 to 3 inclusive. So that'll be 1, 3, square brackets, range. Okay, what's this value? The lowest value here is going, it's minus 1, isn't it, for y? So that'll be 2 minus 1 there, and that'll be 2 plus 1 there. So the range is going to go from, sorry, that's minus 2, sorry, no, that's correct, it's correct. 2 minus 1, 2 plus 1, so the range in values, the lowest y value is minus 1, and the highest y value is 1. So that would be our range, minus 1 to 1 in square brackets. Okay, I'm going to leave the rest to you. Good luck with those. And feed your questions through to your, hopefully you'll have a maths teacher that's standing in for me in the lesson. Please feel free to ask questions of him or her, but also feel free to email me with any questions that you've got. And I will be checking my email on camp, and I'll get back to you as soon as I can on that, with a worked solution or whatever I can do to help. Okay, cheers.